now at the Linux Peter conference of year 17. My name is Vasily Tolstoy, and I'm a member of a programming committee at the conference. And I'm here with Mr. Marek Vasut. Hi. Nice to meet you. Can you present yourself? Tell something about you.
Yeah, so I am a U-boot custodian, Linux kernel maintainer for MTD co-maintainer, and this is what I do, mostly embedded stuff. Yeah, that's what I do, yeah. And I'm also an FPGA hobbyist, actually.
And I know that you do not officially work for a certain company.
Yeah, that's right.
The specific one.
Yeah, I'm actually a contractor, so I'm self-employed and I contract for DENX Software Engineering and a couple of other companies, yes.
Which is a dream for someone of us.
Is that so?
Yeah, to control your life by yourself. It's a dream for somebody.
That's an interesting question. Yes, you get a lot of freedom, but it actually takes a lot of discipline.
Yeah.
To get up in the morning, start working, and actually get some work done. Yeah, it takes quite a bit of a discipline. Yep.
So you are doing a talk at this conference. Can you compress it to a certain degree and talk about it in a few words?
Yeah, so basically the talk I did was an introduction to an SoC plus FPGA, which is quite a modern sort of development in the FPGA area where they add a small CPU core to the FPGA so you can run your custom code on that CPU core and you have it in a single package. So you save on the bill of materials. Mm-hmm. And it's actually beneficial because you don't have to have CPU and an FPGA separately on your board. And this is becoming increasingly popular, so I wanted to show people how to use it and how to use it correctly with the Linux system. Because the current solutions really suck, and Linux has a much better solution for that in upstream.
Great. I had some limited experience with FPGAs, but without the processor core on them.
Right.
But it was absolutely fantastic. Like you can do this, do the real thing by the means of total programming, and
yep.
It does some physical stuff. So it's a great area of interest and of applying.
You can do a lot of things with FPGAs. It's really an exciting technology. The only downside is that mostly the toolchains for the FPGAs are proprietary, except for this one very nice exception, which is the Project Ice Storm. But that's just an FPGA, and it has an open source toolchain. And in modern distros, you can just install that sort of thing, mm-hmm. Just type make, and then use your FPGA. It's super nice.
Great.
I really like that. And I hope more of the vendors will actually mm-hmm. go in that direction and release at least something open source to operate the FPGAs. It is so much nicer and so much easier.
Yeah, I'm sure. I heard sad stories about how much locked it is with the timers inside which stop working and stuff. Oh yes. It's like a zoo of proprietary stuff.
Oh yes. I hope it's getting better.
We will hope. Speaking about the things going around, what do you think? What was the most interesting thing happen in tech world or in Linux world? It depends of what you choose. In last year.
In last year, well, the Project Ice Storm got much wider adoption all over the place. Actually, what happened was that the chip manufacturer Lattice was unable to keep up with the demand, so they ran out of all the development kits with this chip, which was supported by the Ice Storm.
It is Lattice.
Yeah, it's Lattice.
It's a well-known thing.
So, the lead time for that particular dev kit with the chip was 29 weeks. It was unobtainium. That's what open source does to your product.
Great.
Yeah.
It is real proof of what you can gain if you switch to open source.
Exactly.
And do you feel that there is can you name anything which is hype now, which is everybody's talking around saying, that's the greatest thing since sliced bread? You should try it.
Well,
have you heard about that?
Yeah, there's a lot of interest happening in accelerated data processing. Intel acquired Altera 2 years ago, and now they are planning to build a data center grade chip with some FPGA fabric and they want software people to be able to actually program the FPGA, so they are looking into how to do that. And there's a lot of talk about OpenCL on FPGA, so the CPU will be able to produce the content for the FPGA, then you just feed data through it. But I'm afraid this is not going to be open source just yet, which is kind of sad.
Probably there would be partial solution. Yes, the Intel has something to do with the open source, but that's not totally committed.
Yeah. But there's a lot of interest in that sort of thing. Because GPUs consume a lot of stuff, and the FPGA can do like very targeted data processing. And if we got an open source solution for that, that would be amazing.
You see, people keep talking last years that the open source community gets older.
Oh yeah.
And there are some implications, and we should be prepared and do something with it. What's your opinion on that?
Well, yeah, sure, we get older. And I think a lot of people get wiser. I mean, a long time ago...
Most of people get wiser, but...
Yeah. A long time ago, people could be a little harsher around, and nowadays they just mellow a little, which is very nice. And I think it makes the community a little more welcoming to newcomers. So we will kind of snowball in new people and not like... how should I put that? Ward them off immediately with some harsh comment on their page, and so this will reinvigorate the open source community, I believe.
Speaking about getting in the new people, you know, in the area in which you're doing your open source job, in FPGA, it's a peculiar area where you should be at the same time the guy who is doing the classical programming and also be a partial electrical engineer. There are special languages, complicated development kits, specific testing techniques, and it's a thing which takes the knowledge from two worlds at least at the same time.
Yes, that's
what would you say? What would be the best? What would be the typical one and the preferred one? Learning curve, either career path, you can name it as you wish, for the younger people going in this area.
In this area, yeah, that's a very good question. Because you can see, like, some of the engineers of old only know the FPGA and has this like narrow sort of view of the world.
The register goes.
Yes, that kind of thing. So it is always good to know at least something from the other side, so that you can talk to these people who do hardware and actually reach some sort of compromise, so that your software and their hardware will work together well, and that they won't just be throwing it over the wall. And if the software people actually understand kind of how the hardware works, it's a really great skill to have, this one.
And have you any idea how the younger guys who are interested
can
in
acquire
that,
right?
should go in that direction?
I would just tell them to look at the Ice Storm, because this is really like an easy thing to get into, and there's a lot of examples on the internet already. So they can buy a kit for like a couple of tens of dollars. Just plug it into their computer, into the USB, and then just apt-get install or whatever distro you use, the Ice Storm tools, and there they can just get started with that. They can implement their stuff in Verilog. They can simulate it actually with Icarus Verilog on their PC, even if they don't have the kit, and they can experiment with that, build up that sort of knowledge very quickly, and then it's easy for them to just talk to the hardware people. But it is important to respect the hardware people, because they really invested a lot of time into their studies. So they will probably know way more than you do as a software person with a bit of a knowledge from that. But you can build sort of mutual understanding there.
It's a task of its own, but probably there is no easy answer for that.
Totally.
And speaking about the education, what source of information? It could be anything from the classical book to the, I know, video blog, whatever, or some person to follow up on the internet. What sorts of information would you recommend to the general audience? In a sense, like, if you haven't seen that, you should immediately drop any other task and go there and take a hands on that, see, learn, whatever. some nice bit of information source which you know about?
Which I would recommend to any person. Well,
in our trade.
That's a difficult question. I think I would go with the device tree overlays, because this is a hot topic today. All the sort of variable hardware is a hot topic today on the Linux side, on the embedded Linux side. So if you are dealing with any such a thing, look at the device tree overlays. It's really impressive what you can do with that. Yeah. Essentially any sort of Raspberry Pi, BeagleBone with extensible hardware, you can deal with that, with the DTOs. If you have some sort of multiple versions of your hardware and you need to like handle the differences, just put it into the device tree overlays and it's really your problem is solved.
I heard about that. Well, understood a bit, but I obviously never knew that it's that nice.
So I actually spoke about that at the end of my presentation.
Okay. Let's imagine that all the younger people thinking, what should they do with their life? They are a bit inclined into being a programmer or a hardware engineer, or they're interested in idea, the general philosophical idea of open source, but they are not entirely convinced that it's difficult to enter this world, and all they are behind this camera. And you can give them your word of wisdom and say why they should do that and how they can start.
Why they should do that? Because you can learn so much from that. And how they should start, just be persistent, really. Some people can be difficult to approach. I had that experience. Some people can be really scary. But if you're persistent and if you show that you're interested in something and you're willing to invest into it, some of your time, some code and so on, and like send the patches over and over until they are good, the people will actually help you. They will realize that you have the drive, the motivation, and they will help you get the patch in. And the feeling I had when I got my first patch into the Linux kernel, that's amazing. Really, that's something memorable. Yeah. I have to say that. And I believe it was actually Dmitry Torokov who helped me get my first patch into the Linux kernel. I'm sure it was difficult for him to guide me through this process because I was completely clueless. But I got the patch in, and really the feeling is something I didn't forget until now. It's really gratifying. And then eventually you start building your network of contacts and your knowledge. And this is also really rewarding. You also become a better programmer because you get all the feedback from the people in the community, and they tell you what's good, what's not good. And yeah, it improves your skills a lot.
Yes. So, gentlemen, help someone to do their first kernel commit and you will be never forgotten.
Totally.
Thank you very much.
You're welcome.